This video is covering topics 9 and 10 from this semester. And so we are doing lots of things with quadratics in topic 9. And so factoring is one of those things. And these were the kind of different factoring ideas that we had. And so greatest common factor, or GCF, where we are pulling out the common factors from whatever's happening here. So like the one that we did together was 9x squared plus 3x, and so 3x was in common with both of those, and so it's like we're dividing the 3x out of the 9x squared, and 3x is left, and dividing 3x out of the 3x, and just 1 is left. You can distribute that back in to double check and make sure that you did it right, and you get back to where you started. The difference of two squares is a perfect square minus another perfect square, and so you square root this one, you square root this one, and so this one would turn into 2x times 2x, which gives us 4x squared, and 4 times 4 gives us, or times negative 4 gives us negative 16. So one's positive and one is negative, but the values in both sets of those are the same. We're not really going to worry about difference or sum of cubes. But then trinomials and grouping are going to be our friends. So when there's 3, we are looking for two numbers that multiply to give us this number, but those two numbers need to add to give us this number. And then it's x plus that number, x plus this number when they're positive. And so that's kind of the pattern. And your teachers have probably shown you lots of different ways to do this. And so whatever way works for you, that's the way I want you to think about it. And then if we're grouping, there's 4 terms, always 4 terms. And so you can factor out GCF here, factor out GCF here. And then this term and this term should be the same. And so x plus 9 and x plus 9 can come out in front. And what's left in the underneath, underlined in blue, is the x and the plus 1. And so x plus 9 is one factor, x plus 1 would be our other factor. So grouping only works when there's 4 terms. Trinomial works when there's 3 terms. Difference of squares, there's 2 terms, and then GCF can work with however many terms you have. Okay, and so then when it's a trinomial with a number sitting in front, this is where most of us struggle the most. This is a different problem than the one that's listed here, but 3x squared minus 2x minus 16. We take the first number and multiply it by the last number. So 3 times negative 16 gives me negative 48. The middle term is a negative 2. And I'm looking for two numbers that multiply to give me this number, but add together to give me this number. And so that number for me is going to be 6 and negative 8. So because we multiplied by 3 at the beginning, we have to divide by 3 at the end. So 6 divided by 3 simplifies to 2, but negative 8 over 3 does not simplify. So this turns into 3x minus 8 as your factor. So x plus 2 is your factor, 3x minus 8 is your other factor, and then we can take both of those factors and we can set them both equal to 0. So then x would give us negative 2, and this one would be 8/3 when we solve. The other way of solving quadratics is using quadratic formula. And so we have x equals negative b, or opposite b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So a is 3 in this problem, negative 5 is b, and c is negative 12. The thing that you need to remember here is that your equation has to equal 0. So if you need to move things from one side to the other, that has to happen first, and that equation has to equal 0. So then we plug everything in. B is opposite b, so negative 5 is going to be opposite, so we'll plug in positive 5, plus or minus the square root of negative 5 in parentheses squared minus 4 times a times c, so times negative 12, all divided by 2 times a, which is 2 times 3. And then I simplify all the parts that I can. So in the calculator, without the square root, I type in -5 squared in parentheses minus 4 times 3 times -12, and that gave me 169. 2 times 3 gave me 6, and so now I have a much more simple fraction here and can simplify this to the number that it's going to be. The square root of 169 is 13, 5 is still 5, 6 is still 6, and so I can plug all of this in the calculator. 5 plus 3, all divided by 6, gives me 3. 5 minus 13 is -4 divided by 6, which would give me -4/3 or -1.3. We also talked about complex versus real solutions, and so because all of these numbers are nice happy numbers, these, or like this number here is positive under my square root, these are real solutions, meaning I am actually crossing the x-axis. But when it's a complex solution, so these are real solutions, a complex solution is where I'm not crossing the x-axis, meaning it does not have a y value of 0, not intersecting with the x-axis. And so when we solve those equations, we end up with imaginary or complex solutions. And so the same thing is true here. We need to make sure that equation is equal to 0. Everything works the same way like we did on the last problem. So plug in all your values, b, a, and c, and a. And so what happens here is we end up with a negative under the square root. The negative needs to come outside, and that's where the imaginary number comes from. And then I have a real part, that's the 9 and the 4, and then I have an imaginary part, that's the square root of 7 and 4, that's the imaginary part. So I end up with a real plus imaginary and a real minus imaginary to get my complex solutions for my quadratic function.